Hi, this is a brief demonstration of how to use the TI89 to solve a linear system and find a reduced row echelon form. And in this case, I'll take an example of finding the steady state solution of a Markov matrix I've already defined and stored as T. And there's the Markov matrix right here. And I'll go through the steps on trying to find the steady state using the RREF function of the 89 calculator. So first I have to modify the matrix here to give the linear system that I'm trying to solve. And I will use the data matrix editor under the apps button. Press enter and I will say open and I will say matrix and then I will go down and I will select T for the transition matrix and press enter, and there it is, it opens right here. Now the steady state solution satisfies the transition matrix times the vector equals the original vector. So to make that a standard linear system, I have to change the diagonal entries of the matrix. I have to replace them by whatever they are minus 1. And then I go to the 2, 2 entry and take 0.3 minus 1. And then I go to the 3, 3 entry and take 0.1 minus 1. And now I have to add a fourth column, which is that this new matrix times the vector should be 0. So I will enter 0. And notice that it added all zeros to the last column. Okay, and now finally, you remember from the theory that in order to solve this system, I need a fourth equation, which is that the entries of the steady state vector add up to 1. And we do that by adding a fourth row, which has a 1 in every column. So I say 1, 1, 1, and the last one is the sum of the 3 entries, which is 1. Okay, so now I have a 4x4 matrix, which is the linear system for the steady state solution. And we go back out to the main screen, and the way we solve linear systems is we use the RREF function in the catalog. So if I go to catalog and I look under R, now I just happen to have it right there, but you can see RREF, and we press that there, and I will put T and right parenthesis, and this will calculate the reduced row echelon form. And if I do that, you see that I get a pivot in each of the first 3 columns, 1, 1, 1, and the last column tells me the value of S1, S2, and S3. So I know that it should be equal to these percentages right here, and these 3 percentages give me the steady state vector of the Markov matrix. So anyway, that's a brief introduction to using RREF on the TI-89 to solve a linear system. See ya!